Hey yo, welcome everybody. Video every day. This is Kodro and this is Muhammad Bouaziz. And today, as usual, we're gonna solve some lead code problems. So, yesterday we solved these two problems about the fantasy world and the magical world, and today we're gonna solve those two. Those are my account. You can find me on GitHub, you can find me on Instagram and on LinkedIn. So bring your coffee, bring anything you can drink, and let's go. So let's read that. By the way, this is my lead code. So we're gonna start with the permutation problem to find all the spell combination from the given magic scroll. So let's do it. The sound is clear, all things is clear. So here, given an array nums of distinct integer, return all the possible permutation. You can return the answer in any order. So yesterday we solved these two problems, and those two used the combination and the permutation. So I think those two also will use the same thing. So here we have to print all the possible integer in the list. Let's Google a little bit of C permutation Python. Thank you. So, like we see in Python, we have already a predefined function which is permutations, which is from their library iter_tools. Let's just search a little bit about it. Let's read them, some documentation. So the medium implement a number of iterable building blocks inspired by constructs from IPL, Haskell, and SML. Each has been racked in form suitable for Python. So ML, tabulate, count map. So we have those functions. Those are. So we have permutation, all possible ordering, repeated element, and combination. Erlang tuple, insert order, no repeated element. So the permutation gives us tuples of all possible ordering, no repeated element, and this the difference between permutation and combination. That combination it is a sorted order tuple list. So let's just use it. We can just use it. Let's import it first. I think we can import it in lead code. Permutation. That's about perm equal permutation 1 2 for a list print. So it will give us a tuples. I want it to be a list, so we're just gonna append I list of I. So here let's say pos equal equal permutations of nums, and then for an pos we're gonna initialize a empty list, and then we just have to append to it the list of I, and then just return it. I think if we work in Java or C, the problem would be more harder. But in Python have already a predefined function. Welcome everyone to the stream. Hope you're doing okay. So 0. Yeah, it's cool. This problem is easy. So I think we can work on 3 problems today. So I just generate parentheses. So the generate parentheses is to create a balanced magic rune sequence, like rune if you play League of Legends or something. So given n pairs of parentheses, so it's pair, write a function to generate all combination of well-formed parentheses. So n equal 3 parentheses, or 3 3 3 3. Something a combination of first and length 2. I think this doesn't work. Every parentheses have to be closed. So this is rule 1. Let's write a little bit. So this is number 1. How we're gonna check this? I think we can make it on list or a stack. I think I remember this problem. I think we can make them in a stack. Let's roll it a bit. This is from yesterday. Just delete it. Yes. I think we can create this stack. Each element is a parentheses. Let's just divide it. Every element, let's say we have 6, 3 and there 3. If man. Sucks. So we can push a open parentheses. Let's say we push like this. So and we have a counter s equal 0. We initialize it like that, and then when we pull a closing parentheses s, we increment it by 1, so it's equal -1. And if it's closing another time incremented by 1, but if it's a open one, so just incremented by 1, so here will be equal 0. But this function is to check if the parentheses are right or not, but I don't remember a function that can create them actually. It says at length equal 3, so we will have 3 open 1 and 3 open closing parentheses. We just have to change the order of them. We just have to change it. I think there is a predefined also a function in Python, but let's just work it ourselves. So I will have a list. Or I will have 2 variable op, which is the open parentheses, which is 3. I already have n, so I don't need the n. Or op equal close equal cl equal n, which is equal 3. So here we have 3 variables equal 3. The first parenthesis must be always an open one. It cannot be a closing one. So I think we can initialize a, and the last one will be an open one. So here we're gonna change the order actually. It's true. How we're gonna make it? So it's gonna be an open one or a closing one. I think the stack thing is can I just put random parentheses here and then check it with this function? It will be too slow. Should I make a list of 6 elements, which is n multiply it by 2, and 2 and 3. Here will be the first element, which is an open parentheses, and here it's a closed one, and here we can change the order every time we insert a random and then check it with this function. It can't be random. It's a little bit too complicated, but it's correct, I think, and it will take so much time. It will take a lot of time. Or I will just insert a list like this, okay? And then I will grab a function that will change the order of those, but I will put a condition. If so permutation, it will only, this function works on, I think it can work on parentheses or characters. That's right. Not like that. I'll just put a something like that. I think this is not working. It's working, but it's duplicated. It's working. It's working, but it's a little bit too. Oh, and he wants it to be in a single element. So we will have a character. How we're gonna do it? given string. So we can perm list permutation. For perm in list, I should print to join perm. For perm list. Just do some permutation. It's permutation of let's say so okay, so this is the half of the solution. You have to check if the one or more than one parentheses, the opening one is closed or not. So just bro, forget about stack and try. Thank you some recursion. Hey, how are you? Welcome to stream. Khalil Aqerbi, how are you? I'm just working on the parentheses problem. Yeah, I think recursion will help us, but I usually try to avoid it. But I think about. I'm from Tunisia. حتى أنا تونسي. مرحبا 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 أخويا. Recursion. I think I can do it. It's just erase all that. So we will take a string. The len of the string is n multiplied by 2. For example, n equal 3, so it will have 6 character, like 3 parentheses and 3 others. I think this function can. So with the function we already used, we have all the possibilities. The right one and the wrong one actually. Can make, no. It'll be like this. If n equal 2. So it can be like that, etc. So we just have to check. كونكوردي وانا محلول لا قيد فيه راوت اما الغلط ما ظهرتش ورا خدمنا بروجراماسيون مرحبا بيكم. I think that's easy problem, but I'm just complicated it. So if this is closed, let's say it's false. No, cannot. Recursion. We can try it. We don't have to neither insert list or check it. Just have to insert to the recursion. With the recursion, what's the dog doing? So as per your dog is an approach. I was saying I put in the memory D. Now let's take the remaining letter OG. Let's make one word by taking remaining letter, then add them to our first letter one by one. So we're gonna add O and then we're gonna add G, or we're gonna add G and then we're gonna add O. So I have no documentation, oh, the second letter. So it's iterating through the word itself. It's not the same one. Now I have 4 permutations. سيلف دوت ديف لا مانيش سيلف دوت برشا نقرا فيت انجينيري يا خويا شي حاش نقرا انجينيري وما نعرفش نعمل بروبليم تاع بارونتيز تاع الغرب لا فيت نقرا انجينيري و For each part of parentheses, you have to. Vin Smoke, thank you for the answer, but you have two options: either opening a new parentheses or closing an existing parentheses. So your recursive combination will trying both options. Ah, yeah, seems logic. Thank you. Is it really that easy? I think. I hope it's not that easy because I feel dumb actually. Uh, Thank you for the answer, but I wanted to solve it myself. Thank you very much. Function. What the fuck is going here? No. Ah, string equals 0, then return. Then return. جابها كان قصدي don't answer. Oh, so it isn't the answer. Ah, okay. Yeah, either way, I'm just gonna try to solve it myself. No, we're not rushing now. Yeah, we have only 33 minutes. We have full time. Result. That's not recursive. Oh, this is recursive. Okay. So I think it's the same logic. If the parentheses equal open 1, then we can return nothing. But if it's... But here I'm trying to calculate the combination, actually. Return... Let's look more for... Combination... Permutation count. Generate permutation using recursion. No. Count all permutation of an array. I think here the problem is not that we have to close or open parentheses, but we have to count the... we have to generate. We have to generate, not the count. Oh. I thought it's a binary tree. 1, 2, 3, and 1. Combination util. Oh, so it is really recursion on. What time is it? Print combination, data, temporary array to store all combination over 1. Print all combination using temporary array data. Combination util are data 0 and -1 0 enter. What all the parameters are input array, data temporary array, starting and ending indexes in array. So 0 and -1 index, the current index in data, R size of combination. We have n, not R. So to be printed, def combination on the data start and so if index current combination is ready to be printed. If index equal R, then for G range R print data G print return. Replace index with all. I think I have to understand this line. So if index is equal R is ready to be printed, then just have to print it. Replace all indexes with all possible unknown the condition and make sure that including the element at index will make combination of the main element of remaining position. I equal star while I data index array combination neutral. So just we added here array data 0, here array data I plus 1, and then end, and then index plus 1, and then R. To see the difference, array data I plus 1 while I so here I'm sure the stack thing can be right. Welcome everyone to the stream. Hope you're doing right. Hope you're doing okay. Alright, data G. So here we have array data 0 and then data I plus 1, which is and index plus 1. The index plus 1. This variable is what? In data. Current. So this is the index in data. The index in data. That is R. I think we can make a thing out of this. I just want to make sure this time. So data. So here I only have n, and it's the length of the string. Man, I give up. Honestly give up. It's 41 minutes. I have a solution and I will make sure that it works. So let's add another one, and here another one. So here I have all the possible combination. I think that will take a lot of runtime. So I just have to check with recursive. This an easy one. Yeah, I think an easy one. I'm just complicate things. By the way, I usually don't work on lead code problems. I only started when I started this channel about a week ago, so I'm not that professional, you know? I think I want to include some React project, some coding project, maybe apply backtracking, if you know. Honestly, it's the first time I hear of the thing, so I'm just gonna Google it. It's like problem solving methodology, but that's different. Welcome to stream, man. Welcome to stream. I didn't see you. The best solution. But I'm not searching for a. Just want to see the difference. Steps which define the source. The say difference between two such algorithms, branch, or technical pattern is an algorithm. It's a lot of new algorithm. So we have backtracking, branch, and bound. Backtracking is used to find all possible solutions available to a problem. What it realizes that has made a choice. It unsolved the last choice by backing up. It researched the state space tree until it found solution for the problem. And branch and bound is used to solve optimization problem with the result that already has a better optimization solution. No, I give up. I'm just gonna see the solution with YouTube video. I think we lasted about 40 minutes only in this problem. Let's see what's the approach.
So what is ClickUp?
ClickUp is on activity software, anything.
Hey everyone, welcome back.
Yeah.
Let's write some more neat code today. So today let's solve generate parentheses. So we are given a pair, a certain number, n pairs of parentheses, and we want to write a function to generate combinations of all well-formed parentheses. And so you can see that these are the examples, and by well-formed, they basically mean like when you're writing code, you know, you're nesting parentheses, you want them to be nested in a valid way, right? Like we can't have a right parenthesis come before a left parenthesis, right? Like this could not be possible. We would have to do it like this, right? So you can see for each left parenthesis, we have a matching right parenthesis that comes at some point after it, right? So like in the first example, the first three are left parentheses, then the next three are right parentheses. And when they say n equals 3, that means we have 3 pairs of parentheses. So in total, we have 6 parentheses because a pair is 2 parentheses. And 3 are going to be open parentheses, and 3 are going to be closed parentheses, right? So this is a open parenthesis, this is a closed parenthesis. You can see that when n equals 1, there's only one possible way to make them valid, because this is one way, and the other way would be this, and we know that this is invalid. So how can we solve this problem? Let's just try out the backtracking solution, kind of, right? Like a sort of brute force approach.
So you backtrack.
How would we even do a brute force approach? Let's say n equals 3, so then we have 3 parentheses. What does that tell us about valid parentheses, right? Like this is one valid parenthesis that satisfies this condition, right? We have 3 open parentheses, 3 closing parentheses. Well, the first thing it tells us is that we need 3 open parentheses and 3 closing parentheses, right? That much is pretty obvious, right? Like you could probably figure that out by yourself. If we have 3 pairs, then we definitely need 3 open and 3 closing parentheses. So in total, 6 parentheses. But what about the order of parentheses? So let's say so far I'm empty, right? We're empty. Can I start out with an open parenthesis? Yes, I can, right? But can I start out with a closing parenthesis? No, we know that this is invalid. No matter what I do now, this is always going to mess up our parentheses. So we can't start with a closing parenthesis. We can only start with an open parenthesis. Okay, but now let's say I have one open parenthesis. Now what can I do? Can I have another open parenthesis? Yep, because our limit is 3 open parentheses, and so far we have 2, so we're allowed to do that. What about a closing parenthesis? Can I have a closing parenthesis? Yes, because so far our open count is 1, and initially the closing count is 0, and I can, by adding this parenthesis, I'm just changing the closing count to 1 now, right? So now let's look at it. Now can I add another open parenthesis? Yes, I can, because the limit is 3 open parentheses, and so far we only have 1, so I'm allowed to add an open parenthesis. What about a closing parenthesis? Can I add a closing parenthesis right now? No, because you see that so far we have 1 pair, right? This pair of open and closing parentheses, and then when you get rid of that pair, then we're just left with a single closed parenthesis. This closing parenthesis will never have a matching open parenthesis on the left of it, so we can't add this parenthesis. And how would you figure that out from code? Well, just take a look at the count we have so far. Before we add the parenthesis, we had a count of 1 for closed, we have a count of 1 for open. Basically, what this tells us is that we can only add a closing parenthesis if the count of closing parentheses is less than the open count. We can only, if this is true, are we allowed to add a closing parenthesis. So if, for example, if I were to add another opening parenthesis, now we update our open count to 2. So now we have 2 open parentheses, right? So 2 is open, 1 is closed from over here, right? So now I'm allowed to add a closing parenthesis, right? So basically, let's say if we're going to do backtracking, these are the 2 rules that we have to follow. This is basically our base case. Once we have 3 open and 3 closing parentheses, then we have a valid parenthesis formation, right? And this condition tells us when we're allowed to add closing parentheses. We can add as many open parentheses as we want, as long as it's under the limit, which is n, right? We can add up to 3 open parentheses, but we can only add a closing parenthesis if the number of closings so far is less than the number of open parentheses. So with that said, let's start our backtracking solution. So far we're empty, right? So the first thing we're going to do is add a open parenthesis. So now this is what we are so far, a single open parenthesis. Since we added a open parenthesis, that means the count of open is greater than the count of closed. So now we have 2 choices. We can add a open parenthesis, or we can add a closing parenthesis. So we have potentially 2 open parentheses, or a single open and a single close. Okay, let's take a look at this decision. Here we have open is greater than or equal to close, right? And the number of open is still less than 3, so we can do both choices. So from here, we can add another opening parenthesis, so we have potentially 3, and we can add a closing parenthesis, so 2 open and 1 close. From here, we see that the open and close count is actually equal, right? We have 1 of each. So here we don't have any choices. We have to add a open parenthesis. So what we're going to do is have just another open parenthesis come after. Okay, so I'm running out of room, but let's continue. So over here, now we have 3 opening parentheses, right? So we've reached our limit, which is n. So we can only make one choice, and that's to add a closing parenthesis. So now we're going to have 3 open and a single closing parenthesis. Here you can see that we have 2 open parentheses and 1 closed parenthesis, so we can actually add, we have 2 choices, we can add an open and we can add a close. So if we add an open, we'll end up with 2 open, 1 close, and then another open, or we'll end up with 2 open parentheses and 2 closing parentheses. Over here we also have 2 choices because we see we have 2 open parentheses and 1 closing parenthesis. So if we add a open parenthesis again, we'll end up with open, close, open, open. If we add a closing parenthesis, we will end up with open, close, open, close. Okay, so we're almost done. Starting over here, we see we have 3 open parentheses, so we can only add a closing parenthesis now. So open, 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 close, close. From here, we actually only have one choice, even though we have more open. We have 3 open and 1 close, which open is more than close, so we should be able to add 1 of each, but we can't because we know that 3 is the limit, so we can't add any more opening parentheses. We can only add a closing one. So the new parenthesis we add is closing. Here we also have one choice. Even though we only have 2 open and 2 closed, we know that the open count is equal to the closing count, so we can't add another closing parenthesis because that would make it invalid, right? So we can only add an opening parenthesis, so we'll just add a single open. Here we also only have one choice because we already have 3 opening parentheses, so we can only add a closing parenthesis at this point. Here we also have one choice, we can only add an open parenthesis because if we add a closing parenthesis, that would make this invalid because then the closed count, which would be greater than the open count, right? Which we can't do. And so at this point, for each of these 5, we only need to add a single more parenthesis, and since this has 3 open, 3 and 2 closed, we know that we need 3 of each, so the only thing we can do is add another closing parenthesis to it, right? So this is going to be one possible solution because now we actually have 3 of each, which is what we wanted. For this one, we have 3 open and 2 closed, so lastly we are going to add another closing parenthesis. And you might notice that's what we're going to do for each of these, right? Because each of these now has 3 open and 2 closed, so all we need to do is add another closing parenthesis. And for this one, we're just adding a closing parenthesis. And lastly, this one, we're also adding a single closing parenthesis. So now, if you look at all 5 of these, you see that they're all valid, right? And you see they have 3 of each, and they come in a valid ordering. So these 5 are going to be returned as our result. These are the 5 ways we can make valid parentheses.
Losing a loved one is unbearable.
To be honest, it's not that easy, man.
Finally, write the code. This is basically what we're going to do. You can see I summarized it. So we're only going to add an open parenthesis if open count is less than our input n. We're only going to add a closing parenthesis if the closed count is less than open. And we're only going to stop adding parentheses altogether once our open count equals our closed count, which is going to equal n. So I'm going to do this recursively because that's basically the best way to do it. And I'm going to create a stack, which is going to hold our parentheses. And I'm going to create a variable result.
A stack! It's a stack. I know it's stuck.
Of valid parenthesis combinations. And I'm going to do this recursively, so I'm going to put a function backtrack, which is going to hold our parentheses.
Function.
And I'm going to create a variable result, which is going to have our list of valid parenthesis combinations. And I'm going to do this recursively, so I'm going to put a function backtrack inside of another function. So if we have this, then we don't need to pass in these 2 variables into our function because this is nested inside of here. We also don't need to pass n into this function either. But we are going to have to pass in our open and closed count, so I'll call it open n and closed n. So we know the base case is if open n is equal to closed n, which is equal to n. So in that case, we have finished, and basically our stack will contain the proper parentheses. So what I'm going to do is basically some Python stuff, but you could probably handle this with a string if you want. You don't actually need to use a stack, but I just like doing it. So what I'm going to do is take every character in the stack and join them together into an empty string. So once they have been joined together, they will form a complete string. And what I'm going to do is append that to our result list. And once I've done that, I can just return, right? Because this is our base case. Remember, if we want to add a open parenthesis, we have to check that our open count is less than n. If that's true, what we can do is to our stack, we can append a open parenthesis. So just an open parenthesis, and then we can recursively continue our backtrack. And But if we do that, we have to increment our open count by 1, and the closed count remains the same. And after that backtracking returns, though, we do have to update our stack because we only have a single stack variable. Remember, we're not passing the stack into every single call. This stack is basically a global variable. So every time we're done with backtracking, we're going to pop the character that we just added to the stack. And if we want to add a closing parenthesis, we have to make sure that the closed count is less than the open count. So then we can take our stack and append a closing parenthesis, and then we can call our backtrack function, our recursive backtrack, except we'll leave open count the same this time, and we'll actually increment the closed count. And as before, we're also going to need to clean up, so we're going to have to update our stack by popping the character that we just added. And this is actually the entire function, so you can see we broke it up into 3 conditions, which I commented up here, and I explained.
No, it's look easy. What is the thing? So I'm just gonna initialize the stack variable and initialize the final variable and a function that we're gonna need open n and close n. Now I'm gonna initialize the open n equal close n equal n. And now the condition, if open n equal close n, I'm just gonna append it to this to join all the stack. And we return it. So there's elif the open parentheses is greater than the closed one. So we're just gonna append to the stack a closed one. And then I'm gonna recursively open it, but now must add the open this one, and the closed one I'm gonna keep it like this, and then we're just gonna pop the last element. Well, I don't need the elif, but in case, just in case. Then just have to return, just not return it. So then okay. Open n is lower than the closed one. If the closed one is lower than the open one, So we have two. We have one closed and two open. One closed and two open. Or let's say we have two open and one close. Where do we append this? My brain is not braining. So the closed one. Let's say we have two closed. Two closed function. The open one is. So I'll just append. Oh yeah, we can add more. We can add more, yeah. So if the open is lower than, so we can add more, and then open. Have an open plus one. An open plus one. Then it's closed. Stack.pop. Close and plus one. I'll append this. What's we're gonna return? We're not gonna return anything.
Blank in the visual explanation. So the list count, the list of valid parentheses empty, and then we pass in 0 for the initial open and closed count because our stack is initially empty, and then we can return what our result will contain.
Okay, we're gonna return the result, but backtrack 0 0. Backtrack 0. I have to make it backtrack in and then just return this. Return this. Hello, welcome to stream, Hassan. How are you, man? So I'm gonna just return this. Then open. Let's see, I'm gonna backtrack and 0 0. About to. Good. I'm good. Thank you. Backtrack. I think this have to be correct. Hey. Yeah, this is Debian actually. I always work in Debian. Well, now I'm just solving some lead code problems. It's not anything about coding, but this has to be NN. Thank you. Why the output is not? I think the append here is missing something.
list of valid parentheses. So as you can see, this solution works, and it
if open if closed then so open like this. So what type of development you do? Like, yeah, I usually do web dev. I work currently on ASP.NET project and React Laravel project. I mainly develop with web application, but in future I will also try to develop mobile app and software app. Why not? And I could do software testing also, but mainly web development. Yeah, I am. I'm a software engineer student actually. Software engineer student who don't know how to solve this easy problem. Welcome everybody, welcome to stream. Because you're third year, so no. Well, in my country we study for 2 year after the high school. We study 2 year only physics and mathematics. So I did 2 year of physics and mathematics, and then I chose to be a software engineer. So this is my second year as software engineer, which is the 4th year after the high school, actually, the 4th year in the college. So the next year is my last year as a student. So yeah. I don't know why this doesn't work. Just want to print the stack yes. What's the difference between CS and software engineering? Aren't they the same thing? Well, I think CS it's like a bachelor, and then you can choose to work in, for example, embedded, or you can choose to work in network engineer. You can choose to work as a statistic and data and anything, but yeah, I'm just learning software engineer. I learned also some data science, some Python, but I'm focused on a software engineer. Yeah, this is frustrating. Tab 00. Why it's not stack. What? So if equal, oh, so we didn't select it as equal. So it should be correct. Ah, so okay. So that. Wasn't according to me. Well, I guess computer science is more theoretical and software engineering is more of build stuff. Well, build stuff actually. I don't study a lot of theoretical stuff. I'm from Tunisia. It's a North African country. So join return if open. Stock to the front. Those. And then backtrack. Close down. Then backtrack, open up, close down. Start the pop. Should work, man. Open 1 plus 1, close down. Then stack that pop. 0, 0. Actually, I don't know why this doesn't work. No problem. Software engineering also include management and planning. Yeah, for sure it includes, but it has to be more. It has to be known in the theoretical stuff, but he has to build more things. Well, he has to plan first, but then other ones can build stuff. But he has the plan role. Man, honestly, I don't know why this doesn't work. I honestly don't know why this doesn't work. Ugh. Yeah. Like, do I have to just copy paste it to work? What the fuck? Open equal close equal n, then rest of them. It's literally the same thing. If close n, open n, close n. Almost like, yeah, I give up. Bro, you can do one. So please. Monkey type. I didn't understand. What's monkey type? So this the same thing. The rest of the append s, return, and then return s. So let's just copy it. This should work. Also, I didn't do better today. I don't know why. Oh, let's say Python. Search about. Man, I think this is a prank. I will search it in another. Okay, monkey type. Typing test. Ah, so it's a typing test. Search monkey type. Management type. It's speed test. No, I think I'm not that good in that. Well, let's do it. Let's do it. Except plus my keyboard is an old one, so it's not that good. They want I think this is below average, huh? So I have 41 words per minute. This is my first time actually. I have to train a little bit on this. So great. Thank you. So yeah, thank you. Oh, it's above average actually. Okay. I will train on this more to be more speed on to get faster actually on the typing keyboard. Thank you all for the interactivity. Thank you all for watching the stream. Don't forget to subscribe. Don't forget to watch other videos. The last video is the same theme as this one. So I guess this is the end of the stream. Thank you everyone and see you tomorrow. Can I improve typing? Yes, I do actually. So as I said, this is the end of stream. Thank you everyone and see you tomorrow.